So today we're discussing rules, or sorry, properties of logarithms, rules of logarithms. Mostly these are used for solving. They're also used for simplifying logarithms, changing them into things that are easier to work with, depending upon what you're trying to do. Okay. So we have a handful of laws. First one, the product law. The log of two things multiplied is the log of the first plus the log of the second. So if I have one logarithm of things that are being multiplied, I can change that into logs, two logs that are added together. Also, if I have two logarithms that are being added, I can bring that down into one logarithm. Take the things that I'm taking the logs of and multiply them and get one logarithm instead of two logarithms. Okay. Quotient law. If I have two things divided, that's subtraction instead of addition. Okay. Log of v divided by w is the log of v minus the log of w. Take one log, make it two logarithms. Or I can take two logarithms and make them one. Anything that's subtracted, I can do to multiply. And then the power law. This is probably actually the most useful one you will have. The log of something raised to a power is that power times the logarithm. Bring your power down out in front. Or if you have a number out in front, you can make it the power of whatever you're taking the log of. That is probably the most single-used rule of logarithms, is bring the power down out in front, bring the power down out in front, bring the power down out in front. That lets you solve, that's the one that lets you solve for variables in your exponent. When you take the log of both sides, that power, that exponent, the variable that was the exponent now becomes a number out in front. And then you just have x times a number. The logarithm of, let's say, 3 is just a number. So you have x times a number. How do you get x by itself? Divide by that number. That's the one that is probably the most useful one you will use. When you're trying to solve for exponentials, that's the one you use. Now, there are some important rules of logarithms or facts of logarithms that you need to know and understand, and the better you know and understand these, the better off you're going to be. You will have answers and such in the back of your book and answers on the test. On the AP exam, I see these all the time. They expect you to have these certain things memorized. The log base A of B, it's only defined when A and B are both greater than 0. You cannot have the log with the negative base. You cannot take the log of a negative number or 0. Okay. The next one, the log base A of 1 is 0. The log of 1 is 0. Any logarithm of any base of 1 is 0. Because that number to the 0 power is 1. Okay, you need to have that one memorized. The log of 1 is 0 of any of them. These are certain ones you just have to have committed to memory. The log, when you have the log and the power are both the same base, it's just whatever I'm taking the log of. So it's hard to read up here, but you can see it pretty well on the paper. I have A raised to the log base A of B. That's just B, whatever the number is. When the base of your exponent and the base of your logarithm is the same, your answer is just what you're taking the log of, or whatever the exponent is. Okay? Both of those work by extension. Okay? If I have the log base A of A with no exponent or anything, that's 1. So if I'm taking the log of the same number of the base, so for example, this is something you're expected to have memorized when you get around to taking the AP exam. The natural log of E is 1. Because the base of my logarithm and what I'm taking the log of are the same number, it's 1. Every time. Okay? And that's a key fact to have memorized. There are a few things that they expect you to know by heart, The natural log of 1 is 0. The natural log of e is 1. Because they will, on their answer keys and stuff, they'll just have those written down. They won't show why it's that way. There are facts they expect you to have memorized when you get to that level. Okay, there are things I'm going to expect to have you have memorized, or at least understand. When you're taking the log, when they're basing your log and what you're taking the log over the same number, that's 1. The log of 1 is 0 every time. Okay. Now, finding the values of logarithms without a calculator. Okay. So the first one's actually really easy because I just look at the rule that one of the rules I was talking about. Log base 3 of 3 to the 71st power. That's just 71. When these two numbers, when these two are the same, it's just the exponent. Okay. And the natural log is log base what? E. So I'm taking the base of my exponent and the base of my logarithm are the same. Same thing that we just had there. So my answer would be 6. Okay, so those are the easy ones. The base of my exponent, the base of my logarithm are the same number. It's either whatever I'm taking the log of or whatever the exponent is. It doesn't matter. Those are easy ones. Yes?
So because the natural log is same off by the answer to 6.
Because natural log is what? Is log base e. Okay. Now, this one here, we could kind of sort of do it the way it stands, but it's better to combine the logarithms. So this is one using the product law, the log of 2, the two logs added if they're the same base. That's the log of 2 things multiplied. So that would be log base 8 of 64. So 64 is 8 to what power? Yeah, it's 8 squared. So this is log base 8 of 8 squared, which means my answer is 2. Now there is a step that kind of can be used. This is what I like to show. Is that if I use this, I could use the power rule and show why it works that way. Bring the power down out in front. I have 2 times log base 8 of 8, and this is 1, so my answer is 2. Either way, my answer is 2. Because you bring the power down out in front, and then I have the log where the base and what I'm taking the log over the same number, that's always 1. So I get 1. 2 times 1 is 2. So you can always think about it like that. This one here, I need to combine them together. So I have log base 6 of 108 divided by 3. Which is log base 6 of 36. So 36 is 6 to what power? Squared. Log base 6 of 6 squared, which is 2. Now, the next one is a little more complicated, kind of. There's a couple of ways I could do it. Okay, there's a couple of ways I could do this problem. The easiest way is to go ahead and combine those up into one logarithm first. Okay, so I have the log plus the log. So that's 5, log base 5 of 6 times 7, which is 42. Which means my answer is 42. Which is, no Douglas Adams fans? 42. The answer to the question of the universe. Okay. I don't even like those books, and I know that. Now, the other way you could do that one, the other way you could do that problem is you could say, all right, well, when I have exponents, when I have 2 exponents that are added together, that's also log base 5 of 6 times log base 5 of 7, because What do I do when I multiply when I have the same base? I add the exponents, right? So that means I can rewrite them as two powers multiplied together. And this is 6 times 7, which is, once again, 42. So you could do that if you wanted to. I wouldn't expect to do that. The first way is what I would expect to see on the test if I had that test question. But I do want you to understand that there are often more than one way to do one. And the idea of saying, hey, I have exponents that are added, that means it's that base to that power times that same base to that power multiplied together. You have to be able to start wrapping your head around some of these rules of exponents because those are going to be really important when you start manipulating things. Okay? Questions about this? It's not that bad today. Okay. Suppose that the natural log of 2 is equal to A and the natural log of 3 is equal to B. Write each logarithm in terms of A and B. So here's what I need to do. I know what the natural log of 2 is. I know what the natural log of 3 is. So I have to take the natural log of 6 and rewrite that as the natural log of 2 in some form and the natural log of 3 in some form. So I have to rewrite 6 in terms of 2 and 3. Yeah, so 6 is what? 2 times 3, right? So this is the natural log of 2 times 3, which is the natural log of 2 plus the natural log of 3, which is A plus B. So the idea is I take my logarithm, rewrite that as 2's and 3's. Yes.
Is it just A plus B?
It's just A plus B. Because the natural log of 2 is A and the natural log of 3 is B. So in the next one, 1.5. 1.5, right? Natural log of 3 divided by 2, which is the natural log of 3 minus the natural log of 2, which should be B minus A. Next one's a little trickier. Not bad. I need to write 27 in terms of 2's or 3's. 3's, right? 27 is what? 3 cubed. So this is the natural log of 3 cubed, which is, well, what's the natural log of? So this is not the natural log of 3 parentheses cubed. It's not. You got to realize that's what we're talking about. This is not B cubed. Okay? But what can I do? Bring the power down out in front. 3 natural log of 3. So that's 3B. No. Because it's not the natural log of 3 quantity cubed. This is, what am I cubing? 27 is 3 cubed. I'm still taking the natural log of 3 cubed. It's not the natural log of 3 cubed. It's the natural log of 3 cubed. There is a difference. Those two are not the same thing. Those two are not the same thing. This, you take the natural log of 3 and cube it. This, you take 3 and cube it, then take the natural log. They're not the same thing. Okay? You have to understand the difference between the two of them. That is an important difference. Okay, so the next one. This one's a little goofy. What I would do first is get rid of the frickin' radical. Rewrite the radical as an exponent. So this is the natural log of 2/3 to the 1/4 power. What can I do to my exponent? Bring it out in front. So I have 1/4 times the natural log of 2/3. Which is 1/4 natural log of 2 minus the natural log of 3. Which is 1/4 a minus b. Questions? Yes.
So with like A times at the end, we have like 3 and 5 or like 1/4. That means if you were to put like, say starting from the end of A and put 3 in B, that's 3 up to the exponent.
Yeah.
Okay.
If I wanted to. Okay. So the idea is to rewrite them instead of one logarithm as many logarithms. You want to simplify the logarithm part down as much as possible. Instead of one big logarithm, I want several smaller, simpler logarithms. That's the idea. So my first thing is, I have things being multiplied. That's the same thing as the log of individual things being added. So this is log base A of u squared plus log base A of v cubed. Bring the powers down out in front. 2 log base A of u plus 3 log base A of v. Why would you want to do this? Well, it's easier to explain on the next problem than it is on this problem. But it's sometimes easier to work with these smaller numbers. Okay? Back before everybody had pocket calculators, because they've been around a lot less than we've been actually doing math. Anybody here ever see a slide rule? Have you ever seen a slide rule? What? No. What's more complicated? Slide rule is how engineers used to do all their calculations. And it was all based on logarithms. It was based on these rules of logarithms. So let's say I wanted to add a big complex number here. Well, doing the log of that big complex number might be a pain in the butt. But breaking it down to this, much easier to do. 3 times this number, 2 times whatever this number is, plus 3 times whatever that number is, be a lot easier than the log of that. You had tables of logarithms, and that's what they worked with. It was much easier. However, let's take a look at the next one. We'll do the same thing and break it down. Okay. So if I break the next one down, so first thing I want to do is I have things divided, right? So I'm going to have the natural log of x cubed minus the natural log of x minus 3. And then it's an easy step from there. Bring your power down out in front. 3 times the natural log of x minus the natural log of x minus 3. What we have done is we have taken a complicated problem and broken it down into smaller, simpler problems. That's the idea behind what we're doing on this one. Okay, when you get to calculus next year and you start doing derivatives of things, you can do the derivative as the original problem stands, or you can do the derivative as this simpler problem stands. I'm going to tell you, The simplified version where we break it down into easy logarithms, snap to get your answer. The original one, long and complicated, requiring many, many, many rules rather than just one or two. Okay? So the idea behind doing this is to take something extremely complicated and breaking it down to something very simple to do. It is much, much, much easier to work with this simplified version here than it is with that complicated version there. Much, much, much easier to work with. Couple of steps makes your life a lot simpler. Okay. Do number 12. So I'm going to do this over here. Shh. Quiet. So first thing I want to do is break it up into parts. Everything on top is a plus, everything on the bottom is a minus. So I have the log of x squared plus the log of the square root of x plus 1 minus the log of x minus 2 squared. First step, break it down like this. Now, a couple of things. Take the radical, rewrite it as an exponent. So instead of the square root of x plus 1, I have x plus 1 to the 1/2 power. And now bring all your powers out front. So I have 2 log of x plus 1/2 log of x plus 1 minus 2 log of x minus 2. Notice I cannot break it down any more than that because we do not have a rule for the logarithm of things that are added or subtracted. Only logs of things that are multiplied or divided. The log of 2x is the log of 2 times plus the log of x. The log of 2 plus x is the log of 2 plus x. You can't do anything with that. Okay. Questions? Yes?
This is probably just really fundamental, but the fact that the column starts out with brackets, that makes no difference.
No, brackets are just another form of parentheses.
What is the everything up until the minus would have to be its own parentheses, right?
Not necessarily. No. So I have seen that before. If I have multiple things in the denominator, I've seen it where you have minus and then parentheses around the log of this plus the log of that what's in your denominator. But if you just want to put anything that's in the denominator as subtraction, anything in the numerator as addition, you're okay. You're okay with that. Okay, now it's doing the opposite. Put them together into one. Okay, it's not that hard. So for example, first one, log base 2 of 1 over x times 1 over x squared, which is log base 2 of 1 over x cubed. That's it. Next one, a little more complicated. First thing, if I have any numbers out in front, bring those up and write them as powers. Any numbers you have out in front, bring them up and write them as an exponent. Now I have log base 4 of x squared minus 1 over x plus 1 to the 5th power. However, this is not your final answer. What's so hard to factor? Really? You're whining about factoring x plus, because x plus 1 to the 5th power is already factored. Right? No. I'll never make you foil that out. However, You can, however, and should, however, do that. Factor your x squared minus 1. X plus 1, this power reduces by 4. Log base 4 of x minus 1 over x plus 1 to the 4th power. Okay. Do the next one. Okay. Here we go. First thing, take your radical, rewrite it as fractional exponent, 1/3 power. And then take any numbers you have out in front and bring them up. So that would be 21 times 1/3. So this is the log base 3 of x to the 7th. Plus log base 3 of 9x squared minus log base 3 of 9. Now you can combine them up into one log base 3 of x to the 7th times 9x squared divided by 9. The 9's cancel, and you get log base 3 of x to the 9th. And that's your answer. Question. Okay. Change of base formula. Log base b of v is the log of v divided by the log of the base, although I would prefer that we use the natural log of v over the natural log of b. Because you want to start using natural logs as much as possible. Okay. You would get the same answer if you used a common logarithm as you would as a natural logarithm. It doesn't matter. You'll get the same numerical answer. Okay, so you'd be fine on that. However, I want you to start using natural logs as much as possible. Now, so these are all really easy. Log base 3 of 21 is the natural log of 21 divided by the natural log of 3, which is not the natural log of 7. It is not the natural log of 7. It's the natural log of 21 divided by the natural log of 3. You do not simplify. You have to do the logarithm of 21 and divide that by the logarithm of 3. And you would get 2.771 on your calculator. And if you don't believe me, take the natural log of 7 and see if you get 2.771. You won't. This one would be natural log of 15 divided by the natural log of 1/2, which I would do that as 0.5 on your calculator. It doesn't really matter. You get negative 3.907. And I like this last one. Natural log of e over the natural log of pi. What's the natural log of e? 1. So this is 1 over the natural log of pi. And students always freak out, but pi is just a numerical value. Just take the natural log of pi in your calculator. 0.874 is your answer. Question.